In this lesson, we'll be looking at frequency polygon, which is another method of representing data graphically. Now, a frequency polygon is a line graph of the frequency distribution. In our previous class or previous classes, we looked at frequency distribution, which is also a method of representing data graphically. And in doing that, we normally prepare what we call the frequency distribution table. So, and we can use that frequency distribution table to plot a chart known as histogram. So in this lesson, where we'll be looking at frequency polygon, here we first of all draw the histogram and then join the topmost part of each of the bars in the histogram to form the frequency polygon. The frequency polygon is a line graph of a frequency distribution. The frequency distribution is plotted against the class marks of the respective class intervals. The graph is obtained by joining the midpoints or class marks of the tops of the histogram by line segments. That means we are going to, first of all, draw a histogram and then join the topmost part of each of the bars with a line segment. So it's usually in drawing the frequency polygon, one class is added to each end of the frequency distribution. The added classes each has 0 frequencies. As a result, they will touch the horizontal axis. Now we have an example here. The monthly budget of a manufacturing company are as follows. Is given in class marks, class interval rather. From 10 to 14, we have 18 employees. 15 to 19, we have 9 employees. 20 to 24, 11 employees, and so on and so forth. Use frequency polygon to represent the data. Here we need to get our frequency distribution table before we can do that. So the frequency distribution table, let's have the budget. Then we have class marks of this budget. Because we need this class marks to plot the histogram and the frequency. The first one is 10 to 14. The second one is 15 to 19. Then 20 to 24. 25 to 29. 30 to 34. And 35 to 39. Class mark. How do we get class mark? If you recall from our previous class, we get class mark by adding the lower limit to the upper limit and divide the result by 2. So 10 plus 14 is 24. 24 divided by 2 is 12. 15 plus 19 is 34. 34 divided by 2 is 17. 20 plus 24 is 44. 44 divided by 2 is 22. And divided by 2 is 27. 30 plus 34 is 64. Divided by 2 is 32. And then finally 35 plus 39 divided by 2 is 37. So now we need to get the frequency is already given, which is number of employees. So this one we have 18, we have 9, we have 11, we have 25, we have 14, we have 3. So with this information, with this table here, we can plot the histogram. Remember, in plotting histogram from this table, the class marks will be on the horizontal axis, the x-axis, while the frequency will be on the vertical axis or y-axis. So let's do that right away. That is the y and the x-axis drawn. Let's look at the data. The highest frequency I have here is 18. So I need to choose my scale along the y-axis to accommodate that. Okay, so in this case, I'm using a scale of, remember from this board line to this board line is 2 centimeters. So if I have it from here to here, 2 centimeters plus 2 centimeters, that is 4 centimeters. So 4 centimeters represents 10 units. That is the scale I'm using there. So the first data I have up to 18. So let's locate that 18. Then how many this is I want to represent? 1, 2, 3, 4, 5, 6. Let me see this. I'm opening up. 1, 2, 3, 4, 5, 6. Okay. And that will be enough. So 18. The thing should be somewhere here. 18. And the next one is 9. 9 should be somewhere there. Okay. After 9 we have 11. 11 should be somewhere here. And 25. After 25 is 14. 10, 11, 12, 13, 14, 15. The 14 is here. 14. And lastly 3. 1, 2, and 3. Okay, so this is the histogram drawn, but it's not histogram we are trying to draw. We are trying to draw a frequency polygon. Now remember that a frequency polygon is a line graph of a frequency distribution. The graph is obtained by joining the midpoint of class marks of the top of the histogram by line segment. So first of all, let's put the class marks for each of these data. The first one is 12. 12. This is 12. The next one is 17. The next one is 22, 22, 27, 22, 27, 32, and 37. 32 and 37. So we're going to join the top of this histogram with a line segment. We start from here to the middle of this, draw a straight line, join the middle of this straight line to this, and draw this, join this to this, join this, join this to this, and finally join this to this. Okay, let's see the frequency polygon for that data. So that is how to obtain a frequency polygon. The next thing we'll be talking about is frequency curve. The frequency curve is very, very close to frequency polygon. The only difference is that instead of having a straight line like this, we have a curve and a smooth line for a frequency curve. You can see all of these are sharp lines joining the top of the histogram to the next. We join the top of this to this, the top of this to this, and like that. That is joining their class marks with a straight line. For a frequency curve, we use a smooth curve. That is why the name curve. We join the middle of the top of the histogram. And in doing that, we use a freehand instead of using a ruler. It is going to be a smooth curve. So if I am to represent this data with a frequency curve, this is what I will have. Then I will start here. Let's come down. Down, then down. This is a frequency curve for this distribution. You can see the difference. This one is curved, although my curve is not smooth enough, but you have the idea. The frequency polygon we have sharp or straight line. For frequency curve we have a smooth curve.